Welcome, everybody. So I am coming to you late in the evening to do this live stream. I wanted to mix it up from a lot of my live streams that I'm usually doing, inside the classroom right after school. And so what I did is I purchased another monitor. So therefore, I have a little bit more flexibility as far as getting live streams, as far as doing the homework live streams as well as the quiz live streams. And today what we're going to do is cover some polynomials. Hey, call me Emmy. How are you? Glad you get to stay up and work through some math here. So we're going to work on just some polynomials, how to find all the zeros when given. Oh, crap. I forgot to plug in my charger. I'm going to want to do that. So hold on a second. Because otherwise my battery is going to be low, so that's not going to work. But what I'm going to do here is work on polynomials, finding all the zeros when given a factor. And actually, I messed that up. I changed that, and that's actually wrong. This is actually given a 0. So that's going to be find all the remaining zeros when given a 0. You can see an irrational 0. This one we're going to have when given a factor. Then we're going to work on finding all the zeros by using factoring and then writing the equation of the zeros. And then what I'll do is I'll go ahead and take a break. If you guys have any questions inside the chat, talking to you, Alex and Tom. I see you guys. Thanks so much for joining in. But if you guys have any questions, what I'll do is I will just go ahead and take a break. I'll answer some of those. And then what we'll do is we will get into some multiple choice questions that were on the quiz and kind of discuss them, kind of see, how to answer the multiple choice. And then depending on how late it is, I do have school tomorrow, so we will have to get ourselves prepared for that. But depending on how late this live stream goes, I will kind of see if I can answer some questions. So I'm going to dip out, though, of the spotlight here for a second so I can plug in my computer. So hold on a second. Be right back. All right, sweet. We are back in. So, all right, welcome. So you guys, I knew this time is much better than like 3 o'clock right after the right after school is done. It's just kind of easier. For those of you that have been kind of on my channel for a while, I used to, when I first started doing the live streams at the end of last year, this was like the time period that I was going after. And it was fun, and I did it. I was pretty consistent with it for a while. But then what kind of happened is just, the tough thing about doing it in the evening is just, life gets in the way. I have 2 kids at home, so depending on, how the evening goes with dinner and getting them ready for school the next day and everything else, like, sometimes it gets to like 9 o'clock and I'm like, I just want to lay on my couch and not do anything, But then I have papers to grade and preparing my lessons for the next class period, or documents I'm creating for the next upcoming class period. So I'm like, I just can't go live. So it was always tough when I was saying, hey, I'm going to go live on these days, and then I just won't have the energy or even the time to be able to do it. So that's why it was nice to kind of do them after school, because I'm kind of in the mode of teaching and I can just like get right into it. But it was also difficult, too, because, I got so many other things I'm doing after school, and then to try to mix in the live stream. So I was like, what? I'm going to set up my live stream like I had before, and I'm just going to use this as flexibility. And I know the name of the game is letting people know when you're going live, but I think life is just too unpredictable for me to really be consistent in that regard. So then all I ask is if you really care for when to get notified, then just hit the bell notification and you'll know. Obviously, I'm trying to be as best as far as letting people know, trying to be a little proactive. So, trying to get a better idea of like what days of the week I think I'm going to go live, and then at least letting people know like, hey, I'm going to plan on going live, but I'm not sure exactly what time. So anyways, too much talking. Let's get right into the math, and then I'll go ahead and answer you guys' questions that are in the chat. All right, let's do it. So given the 0, find all the remaining zeros of the polynomial. So one thing that we kind of drilled down in my class is, what conjugate pairs. When we're dealing with the irrational numbers, we know that if we have x equals the square root of 2, then we are also going to have x equals negative square root of 2. However, we didn't really cover doing synthetic division, with irrational or complex numbers, because basically what I told my students is, you can do synthetic division with these zeros, but it's really preferred to do synthetic division when you have, rational zeros. And you can do it this way, there's nothing wrong, but then you have to do it twice, and then students are very apt to make mistakes here. So what I told them to do is, rather, if you're given the zeros, just go ahead and write them as factors. So therefore, we could write these as factors by setting them equal to 0 and, basically subtracting this. And what we would have as far as our factors would be x minus the square root of 2 times x plus the square root of 2. And again, just a reminder for any of you that are looking for a little bit more of an introductory, I'm going to be skipping over a little bit of steps that I've talked to my students because this is a review of the quiz. So it's not going to be a full explanation. Obviously, I have videos and notes covering that. So I think I might have wake up on my baby. That wouldn't be good. We might have to coast on the stream. I don't know. We'll see what happens. So anyways, when we have the factors, now what we can do is we can multiply these because this times this obviously does not give you 2x to the fourth, but we can multiply this polynomial. So notice that again, this is a difference of two squares, a minus b, a plus b. So basically I can square the first two term and then square the second term and find the difference, which is just going to be minus 2. I did wake up my child. Crap. So here we have x squared minus 2 is going to be my factor. And basically what I'm trying to do, I'm going to talk a little bit quieter. Hopefully that won't wake her back. Hopefully she can fall back asleep. So we can take the x squared minus 2 and we can divide that. But rather than using synthetic division where we'd use the zeros, we're going to want to go ahead and use long division. So what I'll do is I'll set up the long division algorithm. So I'll have x squared minus 2. Can't believe I woke up my child. Oops. Minus 6x cubed plus 7x squared. And usually she'll go back to sleep. Hopefully. Let's just pray. Otherwise my wife is going to be very mad. And this live stream in the evening might not work out so long. All right. So basically what we're going to do here is whenever we're doing long division, just remember you're dividing with the first term. Make sure it's in the descending order. Everything else is in your standard form. So x squared goes into x to the fourth. Let's do this in red. X squared times, and then you're going to multiply the x squared times x squared, which is x to the fourth, and x squared times negative 2, which is going to be a negative 2x squared. Now, just remember, we are going to put these in parentheses and subtract. Okay, and obviously there's nothing to subtract here. You could use a 0 if you wanted to, right, to subtract them, or a lot of times you just say bring it down. Obviously, x to the fourth minus x to the fourth is just going to be 0. So therefore, we're left with a negative 6x cubed. Here's a big mistake here. It's not 7 minus 2. It's 7 minus a negative 2. So that's going to be a positive 9x squared. 12, you don't have anything to do. You can put a 0x there, but I just, we can see that's not really doing much. So we can just bring that down 12x, and then we can bring down the negative 18. Okay, so now let's go ahead and do it again. X squared divides into a negative 6x cubed. That's going to be a negative 6x times. Negative 6x times x squared is a negative 6x cubed. Negative 6x, negative 6x times negative 2 is going to be a negative 12x. Okay, again, we are going to subtract the rows. So I like to use parentheses with the negative. This obviously is going to give us 0x. This is going to give us a 9x squared. This is going to give us 0x, and that's going to be a minus 18 because you're not subtracting by anything. Last time, x squared divides into 9x squared. That's going to be plus 9 times. 9 times x squared is a 9x squared. And 9 times negative 2 is a negative 18. And if I was to subtract these two rows, guys, you would obviously get 0, but I kind of ran out of space, so hopefully you see that the remainder is 0. And again, what that tells you, and this is perfect, this is really important for us to understand, if we're given a zeros, if we're using synthetic division, we better get remainders of 0. If we multiply them to give us factors, then we better get a remainder of 0. Otherwise, we either did the long division wrong or we multiplied them wrong to get our factors. So it's very important. Now, it's also important to understand that this factor times this factor does not give us our polynomial. So what that means is this times something else gives us that. And that's why we did the division, to find this other factor. And so basically what we have is, if we write this as a multiplication statement, we can say, this wasn't required, but I'm just going to write it in there. We can say that f of x is the product of our two factors that we were kind of given, or we kind of used, and then times our other quotient, right? Because this divides into this that many times, that means this times this equals that. So it's just important for us to understand the relationships with multiplication and division. But what's really important about here, we already have our zeros. Important about this is a factor. And to find the factor, we just need to set our factor, or to find the zeros, remaining zeros, we just need to set our factor equal to 0. So we have x squared minus 6x plus 9 equals 0. Okay? And therefore we can see that this is going to be a perfect square trinomial, which is x minus 3 squared equals 0. So therefore the 0 is x is equal to 3. And that's going to have, but you can see the 0 has a higher power of 2, so therefore it's going to have a multiplicity of 2. So let's go ahead and write the zeros. And zeros are going to be plus or minus 2, and that's a comma, and then 3 with a multiplicity equal to 2. Okay, boom. Now in the next, so in this example, I was given the zeros, but I didn't want to do synthetic division with the zeros, so I multiplied them, give me the factors, so that I could have done long division. However, you could have done synthetic division with those if you wanted to. Just make sure you had to do it twice with both of the complex zeros, or irrational zeros, I'm sorry. Now this next one, you could do long division, and a lot of the students did do long division. However, I like synthetic division, then since I already did one in long division, I'm going to do one in synthetic division. So if I'm given the factor x squared minus 4, right, again, all I need to do to find the zeros is just set this equal to 0. I hate when that happens. x4 is equal to 0, that means x is equal to plus or minus 2. So these are going to be the zeros. So what I'm going to do is, I prefer to use synthetic division. So I'm going to do synthetic division. If you want to do long division, again, you're going to get the same answer. But you have to do long division twice, but it's important to have, when you have two zeros, you're going to take the 0 and put it on the outside of our synthetic division. Now again, remember, we're going to be needing to take in the coefficients of each of our term, make sure in their descending order, and if you're missing a term, then make sure you have a 0 in that place. So we'll have a 1, -1, -7, 4, and then 12. And just remember, synthetic division, it's a little bit different, it's a little bit cleaner than long division. You always bring down the first term. 1 times 2 is going to be 2. Multiply on the diagonals, add on the vertical. -1 plus 2 is 1. 1 times 2 is 2. -7 plus 2 is going to be a -5. -5 times 2 is -10. 4 plus -10 is -6. -6 times 2 is -12. So again, we get the remainder, which we're good. Now, if we were to write out this product, this would be non-factorable. All right. Now, someday, if it is factorable, then you could just continue factoring it down, and you're good to find the rest of the zeros. But I already know through working through this problem, this is not going to be factorable. So typically, when you're given two zeros, you're going to want to do synthetic division twice. And this is the same process you'd have to do in the problem above, just with the irrational numbers. So what you're going to do is you're going to take this quotient, and you're going to put it over here to synthetic divide this. And what we're doing is we're just breaking down the factors. So we're just taking two factors and we're just dividing out the factors further and further. It's like taking, 24, dividing it by 2, and then dividing it by 3, right? You're just continually breaking down the factors to find, to find a list of factors that multiply to give you 24. All right, so bring down the 1. 1 times -2 is -2. 1 plus -2 is -1. -1 times -2 is going to be a positive 2. -5 times -5 plus 2 is -3. -3 times -2 is going to be a positive 6, and we get a remainder. And we're like, woohoo! So, because usually we're done, we like this. We see that this is a quadratic, because remember, that's your remainder. This is your constant. This is the coefficient of your linear, coefficient of your quadratic. If you had more terms like over here, it'd be the coefficient of your cubic, coefficient of your quartic, and on and on and on. But unfortunately, that's not our case. Well, actually, fortunately, it's not our case. We have a quadratic. And we like quadratics because we can typically solve them either by factoring or by the quadratic formula. So what we'll do is, again, this is another factor. Just like we found the quotient here, this quotient is a factor of the polynomial, so therefore we can set it equal to 0. I'm not going to write a product, a product of factors like I did in the last example, but you can do this. We have one factor, and now we just found another factor, which is the quotient, right? Once you divide the factor, say, for instance, 3 is a factor of 12, divide 3 into 12, you get 4, right? So this is like our 4. This is our other factor here. So what I can do is I can set this equal to 0. So let's go ahead and set this equal to 0 and see if it's factorable. X squared minus x minus 3 is equal to 0. And quickly I can see that this is non-factorable. So therefore, I'm going to have to use the quadratic formula. And just remember quadratic formula, x equals opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, so remember that's a 1 there, and that's a negative 1, right? And remember it's ax squared plus bx plus c, right? That's the form of the quadratic. So just plugging in my terms now, I'm going to have x equals, opposite of b is going to be 1, plus or minus, square root, you know, let's get a little close, let's put it down here. Let's do it over here. Actually, let's go over here. So let's do x equals opposite of b, which is 1, plus or minus square root of 1 squared minus 4. I hate when that happens. 4 times a, which is 1, times c, which is negative 3, all divided by 2 times a, or 2 times 1. All right, so if I was going to go ahead and simplify this, this is 1 squared. That becomes negative 4 times negative 3 is a positive 12. So therefore, this is 1 plus or minus the square root of 13 over 2. Now, you could write your zeros like this, or you could distribute the 2 into both those terms and make it written like this. And I believe in the key in my class that I used, I wrote it like that. And it really doesn't matter. Either one. I'd probably say this is a little bit more of a simplified solution, but there's different pros and cons for each one. It really kind of depends on your teacher as well as the multiple choice. But however, we found our zeros 2 different ways. Now we were given 2 zeros, plus or minus 2, right? And then we found these other 2, and I'm just going to write it. Actually, I'll write it like this. So therefore, we just need to make sure we include them both on our list. Plus or minus 1/2 square root of 13. Boom, done. All right, let's go ahead and work on to the next one, and then we'll do 2 more, and then we'll go ahead and take a break for all of you guys that have joined in on the chat. So the next one says determine all of the zeros. So now we're not given a zero or factor. So I don't really, we could go ahead and use the rational zero test to determine possible zeros, but whenever I see a polynomial with 3 or 4 terms, I'm always going to look at factoring. All right, and one of the things we talked about to find the zeros, those are the values that make the equation equal to 0 true. And immediately I can see that each and every one of these terms is divisible by 2 as well as an x. So I factor out a 2x, and I'm going to be left with an x to the 4th minus 2x squared minus 3. Come on, minus 3. All right, and so now what I'm doing is I can see, well, I can use the zero product property, right? I have a product of 2 factors, so I can say 2x is equal to 0, and then x to the 4th minus 2x squared minus 3 is equal to 0. So now I want to still see, is this factorable? And I notice this is a trinomial, and it kind of looks like a quadratic. So I'm just going to say, what, let me just kind of remember quadratics. What if this was a quadratic? X squared, minus 2x squared minus 3 equals 0. Could I solve this using my algebra 1, algebra 2 ideas? And, oops, not x squared, just an x. And if I was looking into that, I could say, yeah, I can factor this. This is going to be, x minus 3 times x minus 1, or x plus 1 equals 0, right? Well, you can notice here, this is the exact same thing here that we're working with. We're dealing with the exact same numbers as here. The only difference is my powers are being raised. For at least the x squared and the x, these are being raised. So what happens here is, watch what happens. When I do this again, I get an x squared. Oops, let's do this. If I do x minus 3 and an x plus 1, you can see here that this times this gives you the negative 2 and the negative 3. But again, I want these to multiply to give me x squared, and I want my middle terms to combine to give me an x squared. So that means all I need to do is just raise the powers. So this is x squared minus 3 and an x squared plus 1. Now I can use the zero product property one more time. Okay, and I'm going to do this in the zero product property. I did talk to my students about how we could, factor using the difference of two squares. I didn't even talk about it here, but like this could easily be factored into x minus 2 times x plus 2. Like noticing those difference of two squares is very, very helpful in this unit. And so we can do the difference of two squares here across irrational numbers as well as across rational numbers. And I didn't ask for the linear factorization, but I'm going to do it as a little bonus to you guys because it is something we talked a lot about in our class, but I just didn't ask for it on the quiz. But anyways, let's go ahead and do the square root method here. So this would be x squared is equal to 3, and this would be x squared is equal to 1. And then if I was going to go ahead and solve here, I would take the square root of both sides. And therefore I'd get x is equal to plus or minus the square root of 3. In this case, x would equal to plus or minus. That is definitely a negative 1. And then remember that's going to introduce our imaginary unit I. Okay, so those are your zeros. And again, when we're given the zeros, going back to our original problem, we can easily and quickly go from zeros to factors, right? You basically just set your zero equal, you set your solution equal to 0, and then that's your factor. So I'll do one of those. Well, let's just get it. So let's write the zero product property, or the linear factorization. So linear factorization here would be 2x, which don't forget about that one. That's still there. And then basically we have x plus the square root of 3 times x minus the square root of 3 times x plus I times x minus I. Okay, and then from here you can see that here's all my linear factors. They all have a multiplicity, so it's just kind of nice to be able to see, when you're doing your zeros. Obviously, we're going to write these nice and in kind of compact in set notation. So we'll have zeros are going to be 0, plus or minus the square root of 3, and plus or minus I. Okay, but rather than using zero product property, you could go ahead and rewrite these as a difference of two squares across irrational and complex numbers, and you'd still arrive at the exact same zeros. So, which brings us up to our final point here, which comes into, well, what if I give you the zeros? How do you write the equation? All right, and again, this comes back to our point, which I was talking about before. Like these are all zeros. All these zeros, you can see these ended with x equals plus or minus square root of 3. So let's just pick one for a second. X is equal to a negative square root of 2, right? To go from the 0 to the factor, all I need to do is set it equal to 0. And I get x plus x equals the square root of 2 equal to 0. This is my factor. And again, a product of factors multiply to give you your polynomial. Right? Your product of your factors gives you your polynomial. So this was one of them, right? And if I wanted to write the equation here, I can write these all as factors. All I'm basically doing is using the inverse operations. So I can write this as f of x is equal to x plus the square root of 2 times x minus the square root of 2 times x plus 2i times x minus 2i. Now again, it comes into your point, like how familiar are you with the difference of two squares? Because when I multiply these out, basically I'm going to get a x squared, and then square root of 2 times the square root of 2 is going to be, or times the negative square root of 2 is going to be a negative 2. This one got a lot of students. X times x is x squared. And then remember, 2 times negative 2 is negative 4. I times I, which is I squared, is equal to a negative 1. So negative 4 times negative 2 is a positive 4. But the problem I saw is a lot of students got this wrong, right? But then what they did is they didn't check their work. Like if you set these equal to 0, you would get these factors, you would get these zeros. So always look into like checking your work, we get confused, right? And we're not sure if what we're doing is right, but kind of work yourself backwards and make sure you got it. And then we can just multiply here by doing FOIL, and for the sake of time and where it's at, I'm just going to multiply this out. So x times x is x squared. Let's do the middle term. So x times 4 is 4x, negative 2 times x squared. So therefore, that's going to be a positive 2x, and then minus 8. Okay, so this was our factored form, and this was our standard form. All right, so now what I'm going to do is just go ahead and take a little break. If you want to go ahead and look at the multiple choice questions while I go ahead and check into the chat, feel free. These are just some of the problems that I gave my students. So we'll kind of see. I don't know. I think I gave myself till like 11 o'clock. So we'll see how long this goes. Maybe we'll have like 5-10 minutes for you guys be able to get into this. Tom asks, is this Algebra 2? It could be for Algebra 2. And this is what I I get on with a lot of my students, in pre-calculus, we cover functions and we cover polynomials. And I taught Algebra 2 for many, many years. This is the exact same topic that they see. I mean, the only difference between what I'm teaching, what I teach in pre-calculus compared to what I taught in Algebra 2 is we don't start with a very basic introduction. We kind of start with a little bit more of like a foundational approach. And then we do, mix in a little bit more difficult problems as well as their understanding of how they connect. Whereas Algebra 2, we're kind of more focused on, teaching really like the fundamentals of the process. But we're not really connecting it. It's kind of like, here's this one process, here's the other process, and like, here's how you do it. And kind of like explaining step by step, but not really getting too much connection and understanding. And that's kind of where pre-calculus, we've been talking a lot, about the fundamental theorem of algebra and, continuity and all these things that are important that are going to help build that foundation for students that are going on to upper level mathematics, for instance, calculus and so on and so forth. David says, basically passed my dual credit calculus class with your videos. You explain how to do is understand concept in too short of a time period. But I know your teachers calculus is a dual enrollment calculus is, it's a tough class, David. It's, I think the hard thing about upper level mathematics, which I'm teaching this year is pre-calculus, is students are just not used to the pace, and I remember when I was a student, it's very difficult to learn something one day, it not like stick, you not grasp it, and then like the next day you're moving on to something else, and you're like, I don't have enough time for that, and there's pluses and minuses to this. Obviously, I think as far as learning mathematics, I don't think learning is the variable. I think time should be available, and I think if we give everybody enough time to learn and to practice, then everybody can learn mathematics. Everybody can we can do so much more with it. But unfortunately, we're still kind of stuck in this idea that everybody has to learn this topic or subject on this kind of timetable. And right now it's just kind of the realities that we're in, and so we have to kind of work within those kind of constraints. So it's tough, but it's just kind of what we have to work, what I'm kind of working in with now, and just trying to see, hence that's why I do a lot of the videos, because I'm like, well, guys, we only have so many classes that I can help you out with, so I'll have these videos, I'll have your answers available for you, so it says by the end of the quarter is the end of the quarter. There's not much else I can do for you or for that to change that. So let's just work a little bit harder, and try to see if we can pick up that pace. Mark says, what is the y-intercept? Please help. So with that forward, we got to find the equation line. All right, Mark, we'll come back to that at the end, and then I will come back to that question at the end. So I'm going to do the multiple choice, and then I'll hit some math questions. Orange Met says, any tips for someone who wants to become a math teacher? Do a lot of math. Just recognize you're going to be doing a lot of math. But it's cool. Like I still remember wanting to be a math teacher when I was a senior in high school. And I don't know how old you are, Orange Mets, and looking into becoming a teacher. But, that was one of my things that I wanted to do when I was in high school. And, it's a lot of work. And I think there's a lot of joys. And I think with any job or any occupation, there's always these ups and these downs. But I think as you're looking into it and, you're defining what kind of impact you really want to make, and how you want to live your life and what you need, I just kind of look into, writing down the reasons why you want to become a math teacher. And, I think the reasons why I've been in the education scene for so long is I've just kind of held on to those, beliefs and things that I believed about education and why I wanted to be a math teacher. And, at this point, those things are still true. And, so that's what's keeping me in the profession. So, best of luck, definitely, Orange Mets, on your journey here. Some of my students watch my videos, Tom. They might be in the chat. Who knows? But yeah, I have kind of some private areas for them to kind of look into. That's a little bit more basic on my classes. But yeah, there's some of them do watch my videos, some of them don't. I don't force my kids to watch any of my videos. There's tons of great videos online, but some of them, stay after school and they do private help with me or they have their own tutor. So, my kids are just like everybody else's kids. Everybody's struggling, and they're trying to find their best. But, all right, so I'll come back to the chat here, guys, and talk with you, but I do want to finish this quiz for the people that actually are like following. They're like, I need these answers. Let's go. So I'll go and finish this quiz, and then I'll go and fill back in on the chat. All right. So number 5 says, list the possible rational zeros of the polynomial functions. Do not find the zeros. So in this case, we're just doing the rational zero test. So again, that was plus or minus the factors of p over q. Just remember, guys, P was your constant, Q is your leading coefficient, and again, it's the factors of your P over Q. So we have 2 over 1 all over the factors of 6, which are 6, 3, 2, and 1. Now, rather than writing these out, I'm just going to do a little bit of investigation here and see which one does not work. So immediately I see 3, and I know that to get 3, I'd have to have 3 over 1, right? So therefore, I'm never going to get the answer as 3. So that one doesn't work. I notice here I have 1 over 6, right? 1 over 6, 1 over 6. This one does not have 1 over 6, but if I write this out, and again, for those of you that are kind of confused, like you can write these out as 2 over 6, 2 over 3, 2 over 2, 2 over 1, even though I said I wasn't going to write them out. And then you do it the ones, 1 over 6, you know, the 1 over 3, 1 over 2, and 1 over 1. But anyways, I know it's not going to be that one. And then I look at the difference here. This one has a 2/3. This one does not have a 2/3. I see that 2/3 is a possible solution. So therefore, that's going to be my answer. You don't need to write them all out like I did. Again, to determine the rational zeros, I just kind of identified the general form, and then I went from there. The next one is find the nth degree polynomial with the real coefficient satisfying the given conditions. N equals 3, which would be the degree, and then you have -2 and x minus 3, 3 plus 2i. All right, so if these are my zeros, then I know that -3 minus 2i also has to be 0. So let's go ahead and write these in factored form, which would be x minus 3 minus 2i and x minus 3 plus 2i. Now, I showed my students to do this using the box method. Also, I gave them a tip of using difference of two squares, which I'm going to use in this video because it's a little bit quicker for me to do. So if I group the first two terms, I can see that I have a difference of two squares. So therefore, when multiplying these, I'm going to have x minus 3 squared, and therefore this is going to be minus 4i squared. All right, so I can multiply the x minus 3 squared. That's going to be x minus 6x plus 9. And you guys can see here, this is, oh, what am I doing? Sorry about that. That's not going to be -4. That's a -2. What you can see is I'm going to have a 2 squared, which is 4, and then I'm going to have I squared, which is -1. So 4 times -1 is a -4. -4 times -1 here, multiplied by negative, is going to be a +4. Okay, that's an x squared, sorry. And then that can factor down one more time into x squared minus 6x plus 13. Okay, now again, remember that's going to be multiplied by this other 0, which gives me a factor of x plus 2. So let's go ahead and multiply those out. So x plus 2 times x squared minus 6x plus 13. Okay, in this case, I'm just going to use a little distributive property. So x times x squared is going to be x cubed. X times -6x is a -6x squared. X times 13 is a +13x. And again, I looked at the answer before. There's really not much I can do until I multiply everything back out, or at least I haven't seen any kind of shortcuts. Now let's multiply the 2 times the x, 2 times -6x, and 2 times the 13. So 2 times x squared is going to be a +2x squared. 2 times -6 is a -12x. And then 2 times 13 is going to be a +26. Okay, so I see a +26 at the end, so that one doesn't work. Let's see here. Oh, I did something wrong. Dang it. We have an x cubed, a -6x squared. What did I get my answer? There's my answer, if I remember correctly. Okay, so that's an x plus 2. That's good. Oh, crap, that's an x plus 3. Dang it. That was supposed to be an x plus 3. Right, because if you slow down, you set this equal to 0, that's -3 plus 2i. If you set this equal to 0, that's x plus 3 equals 2i. And then subtract the 2i. So therefore, it's x plus 3 minus 2i. Good catch. Hopefully, I wonder if anybody got that for me. They comment in the chat. Anybody? Anybody? All right, so that's supposed to be a positive. So therefore, that should have been a positive 6x squared, and then 2 times 6x would have been or 2 times 6x would have been a positive 12x. All right, so now let's go ahead and finalize this answer here. So this would be x cubed, and you can see it didn't make sense, so I had to go back and kind of see where I made my mistake. That's kind of the nice thing about multiple choice. So 6x squared plus 2x squared is a positive 8x squared. So that one doesn't work. So it's between these two. So let's go and check out what our 15x. And you can see here it's 13 plus 12, so that's going to be a positive 25x. Therefore, you can see the answer is D, and then plus 26. Boom. All right. The next one is using Descartes' rule of signs. We're almost done, guys. We've got 3 more to go. So Descartes' rule of signs basically determine the number of sign changes. You guys can see that if we were to see here to do the sign changes, there's no sign changes, so therefore there's no possible rational zeros. If I was going to do f of negative x to determine the negative zeros, you're just going to plug a negative x into each of these. Remember, a negative variable raised to an odd power is still going to be negative, so therefore this would be negative x to the 7th. This would continue positive. Any negative variable raised to an even power is going to be positive. This one would be positive. That would turn to negative plus 2. So now we've got to count the changes. So we go from negative to positive is one change. Positive to negative is another change, and then negative to positive is a third change. But remember, Descartes' rule of sign says it's 3 or minus an even number, so 3 or 1. And you can see here the answer is C. What are the real or imaginary solutions to the polynomial equations? This difference of 2 cubes. So remember, I provided this on the board. So remember, the form is a cubed minus b cubed is equal to, I'm not sure if I have enough space, we'll try it. A minus b times a squared plus ab plus b squared. So basically, if we're going to use our terms a's and b's, basically what we want to do is identify this as, how can we rewrite this as a term cubed minus another term cubed, right? Well, hopefully you can agree with me in saying that I could just rewrite this as x cubed minus 2 cubed, right? So for instance, like in Algebra 2, we would practice multiple of these, and we'd say, all right, well, x is really a, and like b is equal to 2, right? If you guys kind of like compare these two. So therefore, if I was just going to write this out here, I would have, this would be x minus 2. And then I would have, let's see, that's going to be an x squared plus x times 2 plus 2 squared. Okay, now again, it's asking us to give the zeros here. Now you can see here that 2 is definitely a 0. That's part of the factor, so that one doesn't work. But to get these other zeros, you can see we have complex numbers, so we're going to have to use lovely quadratic formula. So therefore, I'm going to set, x squared plus 2x plus 4, okay, equal to 0. So the quadratic formula will have x equals opposite of 2 plus or minus the square root of 2 squared minus 4 times a, which is 1 times 4. Yeah, okay. Divided by 2. All right, and let's go ahead and simplify this. So that becomes negative 2. So 2 squared is going to be 4. And then that's going to be negative 4 times 4, which is a negative 16. Divided by 2. That goes to a negative 12. And hopefully you guys are following me with the simplifying of negative 12. Square root of negative 12 can be broken down into negative 1 times 4 times 3. So that's going to be a 2i square root of 3. So let's finish this off here. So it's a negative 2 plus or minus 2i square root of 3 over 2. And you can see these 2's are going to divide out with everything, giving me my answer C. Right? So the 2 will divide out, so that's a negative 1 plus or minus I square root of 3. So that's how I got that answer. All right, last but not least, guys, and then we are done. Do you think we should stop letter grading? Yes. We'll get to those questions in just a second. All right, last one. Polynomial equation with rational coefficients has the roots 4 plus 2i, or 4 plus square root of 2, and 6 minus square root of 4. Find the additional roots. So, this kind of goes back to this one, guys. If we, way back in the front, we were given the 0. Remember, this conjugate exists, this irrational conjugate. If we have square root of 2, we have negative square root of 2. If we have I, we're going to have negative I. Notice these. Look at plus or minus, plus or minus. The way to get our complex numbers is by taking the square root. The way to get to our irrational numbers is by taking the square root. And if we talked about the fundamental theorem of algebra, they're going to have those two solutions. So you have to do the plus or minus. So when we look at this, last example, if I have 4 plus the square root of 2, I know I'm going to have 4 minus the square root of 2. If I have 6 minus the square root of 4, I know I'm going to have 6 plus the square root of 4, which is really 2, so you got to be careful here. But I think the only two answers here, 4 minus square root of 2 and 6 plus the square root of 4, is going to be C. So there you go, ladies and gentlemen. That is the quiz. Thanks for joining, guys, on this late night stream. I have about 8 minutes left here, so I know Mark said find the y-intercept, so I will go ahead and write that down, and I will get to it, Mark. So hopefully you still are in the chat, so I can cover that for you, help you out there. And then 3 common negative 1. Tom says, do we think we should stop letter grading? I think it's a really complex kind of question. I do appreciate that. I think, I don't think we should stop letter grading, but I think we need to have a better understanding of what we're grading our students for. Like, I think we need to have a very purposeful conversation as far as what is the purpose of education, what is the purpose of people taking math class, what is the purpose of people in high school and college and all that stuff, because I really see that we are kind of going down a path of pushing so much education and grades down students but we're not getting what we need, out of them for a productive society. And I think the long notion of, pushing people going into college, and it's not just about a debt issue, but I think it's really, we look at the education to, serve our society. And, and I think there's too much of a push right now. Everybody's trying to, compete for these. And I think really the jobs of the future is not really going to be much dependent on, what degree you have. I think obviously technology, like what I'm doing with you guys, holy crap, 5 years ago, we couldn't, we wouldn't even be thinking about this or doing it, or 10 years ago, right? So I think it's really cool that the opportunity for myself to be able to have, let's pretend you guys are all in a class. Let's say we're actually doing a class right now. You guys, technology, I think, is lowering the price and it's increasing the accessibility. And I think that's going to obviously have some impacts with education. So, I think grading, obviously, letter grades have a purpose, but I think right now a lot of our educational aspects are focused on the filtering out students, the SAT, ACT. Basically what we're doing is we're just filtering students out. Why students still have to take Algebra 2? And it's like, these people passed Algebra 2, these people didn't. And we can, segregate students based on that, and then, so I think right now it's that, and I don't think that's doing much duty here for us as a school or for the students to really classify people based on that, because it's not just Algebra 2, it's not just the ACT or SAT and all that kind of stuff, and that data is important. I don't think it's I don't think those are a complete waste of time, because I think there is important to look at the data and see how students go, students are doing, but I think it's just kind of gone a little bit too far in one direction, where that's now everybody is concerned about that. Everybody concerns about their grades. Everybody concerns about their test scores. Everybody's concerned about getting into the college. And I just don't think that's going to be our whole picture for much longer. So that's at least my little 2 cents, which I kind of went on a rant for. So I'm going to scroll all the way down here, check into. So Ambrose says, I watch your videos a lot, help you out on Zero Loves. Just want to say a big thank you. Well, hey, thank you very much, Ambrose. I appreciate you staying live. Ali says, thank you. Awesome. I agree. Good. Well, I am pretty passionate about this subject, and you guys can definitely always kind of get me on there. It is something I do a lot of thinking of, and if I had more time, I'd really, really like to do some more videos, talking about the educational landscape. Obviously I get like these great ideas, like, oh man, I want to write a book, and like think about things, and I don't know, maybe as I get my ideas, going through, I'll rewriting them down and I'll make them into little videos or things to talk about. So, Crusade, everyone know in the chat that you'll be a bigger life than I think from programming to engineering. The future is learning towards math with tech. Yes, I totally agree. I think, math is not a dumb subject, but I still think the way that we are teaching math, what we're expecting our students to know is just not really serving a lot. I mean, but obviously there's still a lot of impactful stuff that, we did here as far as our understanding, especially people for going for upper level mathematics, but I think there's so many other things that I could have redone this quiz. Unfortunately, like you guys look at like this quiz, like, oh, you're so passionate about doing other things. Well, why don't you, redo the test? I'm like, I'd love to, but guess what? I'm also graded as a teacher based on how my students do on an assessment. And guess what type of questions are on the assessment? Very basic problems just like this, so it's like that tug and pull. I mean, you can't just go off in one direction, because I probably wouldn't have a job anymore if I did, and obviously, yeah, maybe I could just do everything I wanted to on YouTube, but I could try, but still I think it's, having an impact on one while you're still kind of, trying to work to change the system a little bit. So, all right. Write a book. Thanks, man. I appreciate it. All right, guys. I guess I should probably open up the chat a little bit longer next time. So sorry if I missed your guys' chat. And it's, this is a little bit different than when I do like my 3 o'clock. At 3 o'clock, I get like 10 people coming on. So it's really nice. I get to chat to everybody, ask questions and so forth. Late night, it's, a little bit more busier, so it's a little bit harder to kind of work on it, and I'm a little bit kind of thrown off in my surroundings. I'm not really used to this. It's been almost about 8 months since I guess I last do the live stream in my house, so we'll get used to it though. For those of you that do kind of like this time frame, I will I will be mixing in some live streams. I do want to start doing a little bit of some also live streams on like Zoom to help people out with their kind of private questions and stuff like that. But I'll talk a little bit more about that in the end. Let's go ahead and get on to Mark's question. Hopefully, Mark, you're still on. If not, Mark, I'm going to give you your answer anyways right now. So I think Mark's answer was to go ahead and find the y-intercept. So the way I would approach this problem, Mark, is we have 2 points. And we could obviously plot these 2 points on a coordinate grid. So we have like -6, 3, right? But basically, what we're most concerned about is finding the equation of the line. Now, the only reason why I am kind of plotting this, -3, -1. The only reason I'm plotting this is because I kind of want to get an idea of, where this graph is going to cross. So -3, -1. All right, so if I'm connecting these here, I can see that this is going to cross the y-axis somewhere down there, right? So it's going to be a negative number, right? And it's going to be farther down than -1. So by plotting them, I have a visual idea, all right? So now the next thing I'm going to do is let's write the equation here. So to write the equation of the line, I can first find the slope. So let's go ahead and find the slope, represent m. So to represent this, we'll have x1 and y1. x2 and y2. So again, the slope is -1, or let's just write out the formula real quick. Remember, it's y2 minus y1 over x2 over x1. And therefore, it's -1 minus 3 over x2, which is a -3, minus a -6. Be careful with the negatives. It gets us all the time. So I'm even going to double check, make sure I did that correctly. Okay, yeah. So therefore, let's see, -1 minus 3. So if you owe me $1 and you borrow $3 more, thank you very much, Mark. You now owe me $4. And then here you owe me $3, but you minus a negative. So that's like a +3. So that's going to be a +6, I'm sorry. So +6 minus 3 is a +3. Okay, so my m is equal to a -4/3. And if I make a mistake, let me know, guys, because I'm not familiar with this problem at all. All right, so now what I can do is I can basically click one of these points into my slope point form. And a couple different versions of point slope form, but let's see, y minus y1 is equal to m times x minus x1. Okay, and I could use x2 and y2 if you wanted to, since that's what I use for my points. Doesn't really matter which point you plug in for which, but we have m, and then let's go ahead and use this first point. Actually, let's use the first point here. So instead of using the subscript, I'm just going to go back to y. So y minus y1, so it'd be y minus 3, is equal to a negative 4/3, and times, hey, just watch for fun, how are you doing? Y equals, you can do it mx plus b, that's fine. I'll show you that way as well. But let's do this one because I think it's a little bit easier. Slope is the rate of change, that is correct. So we have x minus x1, which is a negative 6. All right, now what I'm going to do is I'm going to simplify this by adding the 3 to the other side. So I have y is equal to a negative 4/3. That becomes a positive x plus 6 plus 3. Okay, now technically that's an equation of the line. Preferably you probably want this in slope-intercept form. I believe that's what you're asking for. It is rise over run as well. So y is going to equal a negative 4/3 x. Now we do have to multiply the negative 4/3 times 6. Well, notice, guys, 6 is really over 1. 6 divided by 1 is equal to 2. Negative 4 times 2 is going to be a 8. So that's going to be a positive 8 plus 3. Oh, that's a negative. Whew, I was like, uh-oh, I know I needed a negative. Where'd the negative go? So it's a negative 4/3 times 6. So therefore, that's why that gets to a negative 8. And then I get y is equal to negative 4/3. Negative 8 plus 5 is going to be a negative. Negative 8 plus 3 is a negative 5. And you can see, kind of based on my rough drawing here, negative 5 kind of makes sense, right? I mean, there's an x there. But negative 5 basically makes sense. So, all right, guys, this is 11 o'clock. I've been live here for an hour. I think I've hit my quota. But thanks so much, guys, for joining in. I really appreciate it. I am not going to be going live for the rest of the week. I'm actually going to be out of town. But next week I will... Well, actually, we're all done with the unit. So we'll probably maybe take a break. Maybe I'll try to throw in just a fun live stream next week when I return. And, just kind of answer some questions for you guys. And we'll kind of see what works for people. Maybe do it another evening live stream for those of you guys that are kind of chilling, doing your homework, and maybe you guys have some questions. So that will be it. But for right now, guys, I am going to peace out and get ready for tomorrow.